Okay, welcome to Knowledge Search channel. In this video, we will be discussing about what is a full adder. Okay, so what is a full adder? So as in previous video, I have given you a small introduction of what is an adder, binary adder, and what are its types, and how far this full adder is different from half adder and all those things. And in this video, we will be discussing about that if you are really interested in half adder, you please go to the previous video and you can watch that video and come back to this video. So here in this video, we will be discussing only about the full adder. Okay, so finally the full adder circuit after the design, you will be getting a circuit something like this. And it's very simple. Okay, so you can, so hope you know in previous video the half adder circuit, this is nothing but half adder, is it right? So one XOR gate with one AND gate is called as a half adder. So here you will see that full adder is nothing but we need two half adders and one OR gate. Finally it will be concluded like full adder will be equal to two half adders plus one OR gate. So okay, so the one half adder's output will be given to the input of the other half adder, whereas the AND gate output will be given to the OR gate. So like that, and the output of the second half adder will be taken as sum, and similarly the output of the second AND gate will be given to the OR gate, and finally the Cout will be there. So please, it is very simple to understand. Full adder is nothing but a combination of two half adders with one OR gate. So please understand. So how we are going to derive at this particular circuit is what the discussion is all about. Okay. So let us go into the topic. So anyway, I will just have a small brush up. So what is a binary adder? Binary adder is nothing but which is used for addition. Okay, so it is used for addition of the two binary numbers, so which is the basic arithmetic operation in any circuit. Okay, the circuit that performs the addition of two binary numbers is called as a binary adder. So previously we have discussed in a video, and also here it is having two types. One is called as a half adder, the other one is called as a full adder. So in case of half adder, we would have seen that that is the number of inputs is 2, whereas number of outputs is also 2, that is sum and carry, whereas number of inputs can be A and B. Whereas in case of full adder, it is nothing but addition of 3 bits. So half adder is having some restriction that it can only add 2 bits, whereas in case of full adder, you can add 3 bits. Okay, that is normally you will be having the carry in also, which has to be taken into account. So A and B are the two different inputs. Again, the carry in is also the third input. So 3 different inputs are there. That is A, B, and C in. And similarly, the output will be S comma, that is sum comma C out. It is somewhat, the output is similar to the half adder. Okay, so the full adder output is similar to half adder. Only thing is the input is having 3 inputs instead of 2 inputs in case of the half adder. Okay, so hope you are clear. So here you can see that full adder. So what is a full adder? So again, so full adder is a combination circuit. What do you mean by combination circuit? So combination circuit is nothing but it is having gates. Okay, so only using the gates we are designing this full adder circuit. So here we are going to perform the addition of 3 binary numbers. So in case of half adder, we perform the addition of 2 binary numbers. Here we are going to perform the addition of 3 binary numbers. So let us go into the next discussion about the truth table of the full adder. Okay, so you will be clearly understand. So what is the truth table? So here you can see that the 3 inputs are there. So you can see that the 3 inputs are there in case of the full adder, whereas the outputs are. So since in case of input is also you are having one C, in output also you are having one C. So this input we are carry we are naming it as C in, and output carry we are naming it as C out, and this is S is nothing but a sum. Okay. So here you can see that so this is the truth table. So there is you can see that whenever the carry in is 0, it will behave as a half adder only. Whenever the carry in is 1, then only this full adder will come into picture. Okay. So now let us go into the detail. Okay. So this is the truth table for the full adder. Okay. So 0 0 0. So if 3 inputs are there, you have to get 0 and 0. Whereas if 0 0 1, you have to get 0 1. If it's 0 1 0, you have to get again 0 1. Okay, and because you can see that the carry is 0 here. Okay, so again 0 1 1, you can see that the Cout carry should be equal to 1 and sum should be equal to 0. So similarly 1 0 0, you can see that the output will be 0 1 1. Similarly 1 0 1, the output should be 1 and 0. Okay, because both ones are there, so output should be 1 and 0. So if 2 1s are there, the output should be 1 0. If only 1 1 is there, then output will be 0 1. That's what it's all about. But the last one, that is 1 1 1, you can see that the output should be equal to 1 1. Is it right? So if we have two ones in the inputs, that is two ones in input, then output should be equal to 1 and 0. If only one is there, then the output will be equal to 0. So this is what the truth table of full adder is all about. Okay. So now let us go into the detail. Okay. So the truth table we have discussed. So the resultant sum, that is S is nothing but the LSB and C out is nothing but the MSB. So this is the MSB, that is the most significant bit. S is nothing but the least significant bit. So the number of ones in the inputs is the thing which is going to decide the output actually. For example, we have to count the number of ones in the input. If the number of ones in the input is equal to 0, then the output will be equal to 0 and 0. That is, C out will be equal to 0, S will be equal to 0. The number of inputs will be equal to 1, then the output will be equal to 0 and 1. So when the number of inputs is 2, then it will be equal to 1 and 0. The number of ones is equal to 3, then it will be equal to 1 and 1. Is it right? So this is the basic truth table of anything, and this has to be implemented in the full adder circuit. So, and again, as I have already told in the truth table itself, if Cin equal to 0, then you will see that the full adder truth table and half adder truth table are almost similar or similar. Okay, so it is both are same. Okay. So after the Boolean expression simplification, okay, so S will be equal to that is A XOR B XOR C. So this is what the expression comes out. So after the Boolean expression has to be simplified. So the sum will be equal to A XOR B XOR and C. Okay. So similarly, if carry out, that is C out will be equal to A dot B plus A XOR B into Cin. So this is what the that is the carry output expression is all about. So by reducing the expression, we will be from the truth table. If you reduce the expression, you will be getting the sum expression as A XOR B XOR C. Okay. So thus when S equal to 1 for odd number of ones in the input, thus for S, two number of 2 inputs for XOR gate. Okay. Whereas for C out, you need 2 input AND gates and 1 OR gate. So you can see that 2 input AND gate is there, so 2 numbers are there, OR gate 1 number is there. Okay. So from this we can understand that one full adder is nothing but 2 number of half adder, along with that one OR gate is needed. Okay. So if Cin equal to 0, from this we can understand that full adder will be equal to the half adder. Okay. So hope you are all clear with this. Okay. So we have to count the number of ones in order to design the circuit. So for example, in case of S, we need 2 numbers of 2 input XOR gate, whereas for C out 2 input and AND gates is needed, whereas along with that we need an OR gate. So let us go into the circuit. Okay. So finally you will be seeing that. So 2 inputs are given like this, A and B, and the sum of S1 will be given to here, whereas Cin is given to the given as the input to the half adder of the next circuit. Again, the output C1 is given to the that is AND gate is given to the C out. Okay, and C2 output is given to the C out OR gate. So finally, we will be getting the circuits like half adder will be equal to the summation of 2, or full adder will be equal to summation, that is combination of 2 full adder, two half adders, along with that one OR gate is needed. So this is what finally we have concluded. So it needs a full adder in the bit, 2 number of half adder with 1 OR gate. Okay. So here I have written over here. So 2 number of half adder with 1 OR gate. Okay. So we have achieved it. Okay. So thank you very much for watching this video. If you really like this video, please give a thumbs up, and if you have any doubts, please comment. And if you really feel that this video will be helpful to someone, kindly share it to your friends. And if you like the videos which are posted on this channel, please subscribe to this channel and support this channel. Thank you very much. Thank you.